Well, thank you all for coming. We're going to talk mostly about leveraging LLMs for member support, but we will I will talk a little bit about proactive messaging, and we can have some any questions about that toward the end or individually on that. So I am Joe Emison. I'm the co-founder and CTO of Branch. We are a home, auto renters, condo, other personal lines insurance company in the US. So we compete with like State Farm. And an important thing that I think that gives context for this while we're working with Arvind and Kyber, and how I think about things is I'm a big buy over build person, and I very much care about asking, how do we only build the things that differentiate us in our business? And so as a result, we have at Branch, we function very differently from many other similar companies. So there's an auto insurance company called Root that sells auto insurance that venture backed, went public a number of years ago. When they went public, they were in 29 states. They had 600 developers and they were spending about $54 million a year on development. We sell many more lines than auto. So we sell auto, home, renters, condo, umbrella. We're in 36 states in DC. We have 20 software developers. And our annual software dev spend is about 2.3 million. And also our Amazon bill for production is less than $10,000 a month. So there's a lot of things that we're doing differently. And so I have written a book. It's out. It's coming out in November. If you want, if you use the discount code Emison and you go to Informit or informait.com, you get 35% off on it if you want. It's also on Amazon. You can't get the discount there. That talks through this philosophy more and how we approach serverless. So just to give you broad-based background on how I like to think about things. So this is Arvind. He's the founder and CEO of Kyber. Wrote a great cold email to me quite a few months ago.
Here we are.
Yeah. And was very young at Google. I guess he can talk a little bit about being tech lead for user modeling platform.
Oh yeah. Former Google engineer. I was at Google for 5 years. Tech lead for their user modeling platform, how Google knows who you are, what your interests are, that type of fun stuff. Left Google about May last year to found Kyber, went through the recent Winter 23 batch for YC, and here we are today. So cool.
Yeah. So let me give you context for this workshop then, and then Arvind is going to lead you through the workshop itself, and then both of us can answer any questions you have for us. So context for Branch. So Branch is built to sell to the high lifetime insurance customers. Those are the people who bundle, and by bundling I really mean home and auto insurance. So Branch's policy bundle rate is about 56%. You can see Progressive and Lemonade are bundled 10 and 8%. And so these are like what we have been able to achieve in the market is no one has done this since like State Farm in terms of how do you attract these customers. But when you do this, it's like a Lemonade or a Progressive are trying to hit like easier, cheaper policies, or like I need insurance now, give it to me now. And so in this context, we need very good high touch member support. And so we have specific principles. So we don't run you through a chatbot initially. So these are our member experience principles. They are based around however you want to come to us, so SMS, chat, email, phone, how do you get to us? How can you talk to a person if you need to? But obviously we'd like to deflect you to self-service if we can, and a lot of people would prefer self-service. But in light of this, we can't just have let's just throw a chatbot in front of every interaction and just hope that people are satisfied by this. We really want to have this last principle on this of we treat members like members is very important to us. We want you to feel like you're part of this community and that you're being treated the way if you ran an insurance company you would treat people. And so as a result of this, we have ended up over time building this stack for member experience. So let me just talk a little bit about this. So one of the trickiest things for us, we started with Zendesk, and we had to leave Zendesk because we do lots of proactive messaging. So when we're going to bill you, we want to proactively message you. We're going to charge you this amount in this many days, right? When we've billed you, or if it failed to bill, we want to let you know that as well. There's a lot of things in insurance where we need forms signed. It's all variable to the customer. And so we use services like Customer IO, Iterable, to do that type of communication via email and SMS. The problem that we had with Zendesk was that if you text out through like a Customer IO, Iterable, Braze platform, the response gets thrown away. And what we really wanted was we want to send you a text message and have you be able to reply to it and start a one-on-one high-touch communication. The only way we could do that was using Twilio as the main way to send the SMS and then having front attached to the responses to Twilio. And so by setting that up and by having front be this omnichannel hub that we have, every time we send any proactive message, so SMS, and again, we have this short code 230. I mean, and you can buy a policy that way too. Every text message that you get, you can reply to, and it instantly starts a conversation. You don't have to go to like Apple Business Chat. You don't have to wait to be connected to people. It just automatically starts that conversation. And so same things like in the app, you get a notification, you're able to open up a chat in response to the notification, and then all of that communication that you've had is visible to that rep. So that's very, very, very helpful. And so we really care about these back and forward. How do we proactively communicate with you? And then how do you respond and immediately start a conversation with someone? But it's expensive. And when you make it easy, people get kind of lazy. And so if you can get connected to someone and talk to them within 60 seconds, a lot of people are going to call you for everything. I mean, the average age of one of our customers, I think, right now is about 52. And so we get a lot of calls. So when we saw some of the benefits of OpenAI, ChatGPT, we felt that there were going to be some real ways that we could optimize the way we handle these communications, both within our teams, right? Because we have member support people we call, and you can think of every state has its own insurance regulations. Our product in every state is a little different. And so there's this immense need to be able to search and understand what is true about us, this program we have in this state, right? Even for our own staff. And so we have been working with Arvind and Kyber now for a number of months. I don't know when we started. More than 6 months?
February?
Yeah, I think that sounds right.
6,
yeah. And there are a number of amazing uses that we've been going through, finding the information we have, summarizing massive amounts of communication we have, and automatically building claims letters. And so we do all this. Just one last note on this diagram. This is fully serverless. So like we don't have an internal network. We don't run Kubernetes. We don't run containers. We don't run virtual machines. All of this is hosted managed services that are communicating with each other. We do have custom code that we're writing that makes some connections between things. But everything is living in Amazon Web Services as the production environment. Okay, so that's the summary of that. I'm happy to answer any questions about any of those things that I just talked about. But let me turn it over to Arvind and let's go through the workshop.
Yeah, cool.
Good.
Any questions real quick on that or no? All right, sweet. So then, yeah, I'm gonna run the workshop off of a GitHub repo. So I'm gonna pop that open, download it, or clone it, and then we'll just get started. So let me know when you're set up. There's some prereqs, part of the setup. Basically,
do you want to leave that up there for a second more? Oops.
Cool. If you're ready, yeah. Just okay, cool. Yeah. So anybody else need the link, or are we good on the link? No? All right, cool. Yeah, so there's just a few prerequisites to get started. Definitely make sure you have Node, ideally version 18, and test with any prior ones, but it should be fine. Docker, OpenAI API key, and a fly.io account. Also, just recommend downloading Postman for the sake of ease, unless very comfortable, like running with the curl, totally fine as well. And yeah, just let me know when those things are kind of set up, and we'll get started. Really, the goal is by the end of this workshop that you'll have like a microservice deployed on fly, callable, usable Node.js little microservice that you can then use to actually get like factually correct answers to just simple questions about branch insurance. How many people here have actually already started playing around with like OpenAI, large language models, familiar with it? Okay, and then how many people have like played around with even like the embeddings, started playing around with like, okay, cool, yeah, and then cool, yeah. So we're not going to use anybody like how familiar are we with like LangChain and those types of things? Got it. So we're not going to use LangChain because I think there's a lot of like things that get obfuscated under the hood. And we're just going to go in raw and really try to understand how the overall flow works. But cool. Let me know when you have kind of the prereqs set up, and we'll just start digging in. Way to test just to make sure. Maybe just getting through steps 0 and 1, where you can just install dependencies, get the server up and running locally, and then just make sure that you can hit a request against it to get started.
Random question on the OpenAPI, like after you've logged in, put the OpenAPI or API portion of it.
Mm-hmm.
Somewhere in there, there's going to be a API key.
Yeah, so you're gonna want to go into like your profile and go to like, go to usage and billing, and then just generate a key. Once you create, I think you should be able to like re-access it and everything, right? So it's not just, okay. No. Yeah, I tried hitting up OpenAI to say, hey, give me some credit codes before I got here, but I did not get a reply. Or they tried to send me somewhere else, but it's okay. Shouldn't be too intensive. Let me actually turn my Docker on. Speaking of which. Also curious, how many people have has anybody played around with fly.io before or Familiar with it? Okay. So it's actually just as a quick like brief. It's kind of like its own hosted cloud. The idea is that they automatically manage spinning up proxies located closely to your users. It's almost like a CDN network, but on top of your own like deployed microservice backend, right? And then they just basically provide a container, spin it up, and then as your user traffic kind of comes in, they're spinning up these proxies, automatically managing, and then like load balancing that, so that you basically get minimal latency on top of like the container that you're deploying. So it's really nice. Don't have to worry too much about it. Take care of everything, and it's just like way easier to spin up and get running than I don't know, wrangling with like AWS Lambda or something. And sometimes, sometimes.
No, there's an interesting aspect of like if your developer experience is primarily around containers, like you want to deploy containers, right?
Yeah.
And it's just like, how do I deploy containers more easily? And so there is fundamentally a different way of thinking of applications as like, how do I stitch managed services together? Yeah.
Mm-hmm. Yeah. So, yeah, cool. Okay. Anybody stuck with any steps, or are we kind of good to run? Can people get it running up and like running locally? Have you guys tried throwing a request at it? Are you getting a little like hello world message back? Should be, yeah? Thumbs up? Yeah?
I'm stuck in brew right now.
Okay, stuck in, okay. We'll wait. Yeah, I get it.
You can power through it.
No, it's okay. Yeah, I mean, I was anticipating with the installs and stuff. So we'll get going shortly. Cool.
I've got it. It's installing. I've done all the things on the README right now.
Okay, cool. All right, so let's get moving then. All right, so everybody has this thing running locally. We got some new. Just really quickly before we dive too far ahead. Oh wait, where did the? Oh, here's the presentation. Oh, no, that is not the presentation. Where'd it go? You're just going to want to go to, if you want to download the repo, it's going to be github.com/asontha/LLM support, LLM_support_workshop. Cool. Okay. So there's some prerequisites. The README is like super in depth, but basically we're going to start off on step 1. Cool. So everybody has the repo running locally, able to hit it. Yeah, you're able to get this message, hello world. That's kind of the default. So let's just go over kind of a code structure really quickly. Basically, you have your root file, index.js, single route defined on it right now, /answer. And then if you go into routes and /answer, you'll see another index.js. This is where the bulk of our work is going to happen, right? So this is the route. We're going to go in. We're going to start adding some cool, fun stuff up here. So yeah, let's start digging in. So step 1, really, I think, what are we creating, right? Like, what's the objective? We're creating a microservice that can just answer questions, right? Majority of support, like workloads, work cases, really are just trying to understand, refine, get answers to questions, and starting off with that basic, simple case to start off. We're going to create our request and our response bodies as so. So our request body is basically going to be like, okay, question, hey, like, what is branch, right? And our response body is effectively just going to be like answer, the answer to whatever, So to do that, just to start off, we're going to start off by defining, let's just update answer handler like so. We're just going to go in, we're going to paste provided code into our handler over here. And effectively all we're doing is we're just checking for that question on our request body and then responding, with that. So the answer to your question is whatever. So if we run it, and then we go and we hit, let me just, not format raw. Cool. Answer to what is branch is. So, makes sense. Easy peasy. Good? All right. So once we're past that, let's start getting the LLMs installed. So next step, let's make sure to install the OpenAI Node.js SDK. So super simple, npm install, npm I if you prefer, --save OpenAI. And then off of step 0, or as the prerequisites, you would have gotten your OpenAI API key. So make sure to go and drop that into the .env file that's provided. And that'll just set it up. The OpenAI SDK is automatically just looking for that environment variable. Or actually, wait, no, I think okay, yeah, we'll be going in and we'll be configuring that key in. But once we're there, just let me know. Cool, so save. All right, drop the key in. Good? Yeah. Okay, cool. So the way that you want to just go about configuring the SDK is you just want to drop in the OpenAI configuration along with the overall configuration, and then we're just going to define our handler or our client basically at the top of the file. Cool. good? Yeah. All right. Cool. So now we have the ability to call OpenAI. Now really the goal is like, let's just start throwing some questions at it, seeing how it handles them, seeing what happens. What does like those basic calls just directly to OpenAI look like? So the way that you want to do this is basically right after we define our question, let's start looping in, some of these calls to OpenAI, effectively using, the SDK to create a chat completion. So the way that a lot of for these chat models, the way they're structured is you have system and you have user prompts. We're just going to be using the user prompt right now, and I'll dive into when you use the system prompts versus these user prompts. But effectively, you're just going to want to take these and drop them in right here. So what this code is doing is we're defining the prompt that we're actually going to be using against the large language model. Right now, it's super simple, just user, with the question that we took from our request body. The model that we're using is 3.5, so your standard ChatGPT model that you're using directly from OpenAI when you pop open like chat.openai, throwing in those prompt messages, then the chat completion basically contains what we're getting back from OpenAI, and all we're doing is we're just taking, typically OpenAI will return one option, so we're just going to take that first option, take that content, and then use that as the answer. And then ultimately our goal is, to reply with that answer for our microservice. Cool. Actually change that in const. All right. So if you actually go in now and we start, what am I missing? Line 19? Yeah, it's just wrapped.
I got there, but I thought maybe it was a version of Node.
Let's see. Did they? 1 second. Yep. Yeah, I have a feeling there was a recent SDK update. 1 second, which is always fun. So let's pop open this guy. Let me just check. 3.3. Git branch. Yeah, there you go. Major version update. Okay, well that's always fun. So I'm gonna recommend. Dude, this I'm like a couple weeks. Doing it live. There you go. All right. So I'm gonna recommend, so that the workshop doesn't break, you upgrade. You set your OpenAI version to 3.3 instead of 4.2, so that things work as I expected them to. But cool. There you go. Oh, I think I need to drop my. One second. I'm just going to disconnect really quickly for half a second. Cool. All right. Okay, so cool. All right, so do we have it running? We're able to connect to OpenAI. We're getting some responses. Talking to ChatGPT. Great, right? So now, if you ask it a simple question, for example, like this, right? Like, what is branch, right? The goal there, what we would want it to say, especially in the customer's context, or when you're, in managing support, right? You don't want it to say, oh, in the context of computer programming and version control system, a branch is essentially a separate line of development within a project. Like, that doesn't sound really good, right? Now, okay, well, what we could do is we could say, hey, well, the user should be smarter and be like, oh, what is branch insurance, right? And now, based off of what's going on, okay, we see branch insurance is technology-driven insurance startup, offers affordable and sustainable home and auto insurance policies. Pretty impressive, okay, right? Now, but that's just like lucky. We're lucky that this large language model, and we're lucky that Joe and team had a bunch of awesome resources online that was easily digestible. This large language model went in, it pre-trained on a bunch of it, and was like, okay, cool, I can kind of spit some of this information out, right? And it actually does pretty well when we start to ask questions even to like, who was branch insurance founded by? Let's see. I think I tested this. And I think, yeah, there we go, right? Steve like us and Joe Emison, right? Steve serves as CEO while Joe is CTO. All right, pretty good, okay. But now, if we start to say like, what states is branch insurance available in? So it's going to do a pretty good job with this answer. I'm not worried about the answer looking good, but what you'll start to see is, okay, so we have 1 through like 31 states, right? Arizona, it's actually it's like nicely formatted in like alphabetical order, but watch what happens when I call it a second time. Right? Notice how we went from 31 states to 30 states. Notice how we go from 4 states. Notice how we go from, let's see. Okay, this time we have 24 states. I think that one's right, Joe. Right?
No, 36 plus 1.
36 plus 1.
So
oh.
DC, 36 plus DC.
Okay. All right. Let's see. Maybe if I hit it again, like then we can get the right answer, right? Okay, no dice, right? And so the reason is, the LLM really has no idea what's going on, right? So the way that these large language models are trained, and the reason it's called GPT, right, is general pre-trained transformers. Basically, give it a big chunk of data beforehand. We're just pre-training on that, and then what we're doing is that's just unsupervised big chunk, basically like preloading the memory. The way I like to think about it is almost like a kid going through grade school. And then what you're doing is you're actually fine-tuning it into those like specific tasks so that it actually says things that are actionable, knowledgeable, smart, right? So anything that kind of gets cut off as part of that like knowledge cutoff as part of that pre-training step kind of counts as like some of the memories and some of the information that it's pulling from. Problem is like none of it's grounded. It's all kind of like all over the place. You have no real like grounding point, no real truth to it potentially. So how do we fix that, right? Really, the first step to fixing some of these problems comes in the form of just prompt engineering and adding some additional context, right? So to do that, what we're going to do is we're actually going to start using the system role prompt, where what you're doing is you're not the user kind of interfacing. You're saying, hey, I am this third user, I'm the overarching system, and here are some like brief guidelines and things to follow with regards to how you are, performing or what kinds of outputs you should be saying. Here's some like high level guidelines. It's not perfect, by the way. That's a whole nother problem with regards to large language models, is very easy to kind of hack. And so that's all some of the other fun stuff that any kind of LLM-based application has to deal with. But to start off, we're just gonna add some additional context, add a little bit of prompt engineering, keep it a little bit more focused to the tasks at hand. So to do that, first step, let's add in this build prompt function. So you'll see the build prompt function effectively taking in the question as input. What we're doing is we're going to be using the system role at the beginning. we're going to be adding a hat. We're going to say like, hey, you're a support agent for branch insurance, and you answer users' questions, okay? And then here's some additional information about branch insurance. And what we've done is we've just taken the website FAQs. So, what is branch? What makes branch different? Who is like General Security National Insurance Company, one of the like backing underwriting carriers, where are they located, et cetera. So let's go and let's drop that in. Cool. And then to wire that function in, just make sure that you go and you update the prompt messages variable to actually call the function.
Are there triple quotes like symbolic for the prompt engineering portion?
Great question. Yeah. So what I've just seen is that with triple quotes, you just get better delineation and breakage between. You can use like triple quotes. You can use dashes. I've seen like just something that kind of indicates breakage between sections so that they don't like merge between each other. Here, by using that, what I'm clearly indicating with the triple quotes is just like, hey, here's some additional information about branch. And by wrapping it in triple quotes, I'm very explicit about what the additional information that I'm providing with branch is. And that'll actually become very important as we kind of go into the next steps, where we start to go into like retrieval augmented generation and start to pull in additional context like this a bit more dynamically. But yeah, okay, so we're good? All right, awesome. So yeah, now if we go and we just run our service again. So this question right here of like what states is branch insurance available in, since like context within like the FAQ doesn't really contain that, what you'll notice is that the questions that you ask it, if they are pulling from the context, they'll have a really good idea with regards to how to answer them. So for example, if we start to ask it certain questions like, okay, actually let's start off with like, what is branch? So remember, we've actually given the LLM a hat. We've said, hey, you are an insurance agent, you are a support agent for branch insurance. So now if we actually go and we ask it the question, instead of talking about, branches in programming or like how programming branches side to side, whatever, now you see it's actually just focused on talking about branch insurance as a tech-forward insurance company that aims to make insurance better. You get like, in-depth information about when it was founded, what makes it different. You can even see it broaden some of the additional context information around General Security National Insurance Company or Everspan, some of the other backing carriers that branch uses inside of other states, right? And then you can now just start to ask it like other questions, right? You can even ask it like, who are you? And if you remember, as part of that prompt engineering piece, it's going to say, oh, I am an AI support agent for branch insurance. I'm here to help answer any questions you may have about that company or its products. How can I assist you today, right? Simple prompt engineering techniques that start to actually shape what this LLM believes like its task at hand is, instead of just being wide open like, oh, I do AI and I am AI trained by OpenAI, et cetera, right? That's not an ideal use case when you're trying to help with specific customer support. Cool. Any other fun questions? Anybody else try anything that they want to see or that they think is fun? I don't know. No?
Well, if you ask it what states they operate in, it actually says it doesn't know, which is better than false answers every time. So that was kind of cool.
Cool. Let's try that, yeah. Okay. Yeah, not perfect, but that's actually the fun of dealing with LLMs is, they're just so non-deterministic at times. But yeah, these are problems though that now we have a bit more tooling around that we can now start to approach to solve with the additional data that we have, right? Cool. So, all right, so we tested some questions, we saw some fun stuff. Now, as we saw, there are limitations. Most knowledge sets don't simply fit within the context windows of these large language models. I can't just throw, the entirety of them in there, and they'll just figure it all out. Furthermore, in the case of Branch, it's a regulated financial product, right? Insurance is a highly regulated financial product, many nuances at like the state levels. Therefore, what we need is like an algorithm that can cut through that noise and pull in like the right pieces of data at the right point in time. And so that's where a common technique known as retrieval augmented generation starts to come in. So that's a big fancy word. Short form is RAG. But really all you're doing is you're doing a pre-processing step before you go and actually call the LLM. What you're doing is taking a search index to go and find kind of the most relevant contextual pieces of information before you go about calling the large language model and saying, hey, now go execute, find me the answer to this, dig through all of that context and kind of resolve it back down to that super simple answer that we just ultimately want. So how does this thing work, right? So step one, we're going to be initializing our search index. And for our search index, we're going to be using a method known as semantic search. The way that semantic search differs from standard keyword searches or whatever is that what you're really looking at is the semantic similarity or just how similar two words are, right? So like red and blue are similar because semantically, they share, they're both colors, right? So semantically, they're very similar to each other, even though if you were to use like keyword search, red would not pull up something like blue, right? Red is much closer to, blue than it is to the word banana, for example, right? Yellow is actually pretty close to both, potentially, right? But red and blue are much closer to each other than, say, red to banana. So how does that work, engineering-wise? Like how do we start to get to semantic similarity? What are the methods that we can use? And the most popular one really is around embeddings. Two types of embeddings, typically. You have dense vectors and you have sparse vectors. We're going to be using dense vectors, but the idea really is to take something in high dimensional space, like language, right? Think about all the different types of words there are. If you were to try to represent every single word in the English language, you'd have like a huge dimensional vector of like zeros and ones and whatever. Every time a new word was created, you'd add another dimension, you'd throw like a 0 or a 1 onto that to be like, okay, that word's referenced, right? So instead what we do is we basically take that high dimensional space and we compress it into lower dimensional space. And that dimensional space is like effectively represented by the number of like digits or like floating points that you effectively have. The easiest example to think about this, coming back to colors, is like RGB. What you can do with RGB is you can represent basically large gamut of colors, right, with just 3 values, right? And the closer those values are to each other, for example, like you have, the closer those values are to each other, the closer those colors are to each other as well, right? The farther away they are from each other, the farther away those colors are, and it's the exact same thing that's happening. With embeddings, we're just applying that to text, right? So to start off, the way that we're going to do this is we're going to just use like a local vector DB called Vectara or Vectra, right? So next step, let's just install that. And we're actually going to end up generating our embeddings out of OpenAI and just kind of sync those in. We already have a little bit of like predefined data ready for you guys to start kind of looping that stuff in as well. But yeah, cool. So from here, let's kind of set up our local index. And then for this, we're just going to be doing, for the sake of the workshop, we're just going to be doing like a lazy load of the index. So on the first request that your backend gets, it's just going to go, it's going to pre-process and like preload. But normally what you'd probably want to do in like more of a production setting is just kind of like pre-process. What we have, of course, is just like data pipelines that are constantly running in the background, refreshing that data, pulling into multiple different data sources, dropping those into different types of vector databases for different use cases, different chunking strategies and all of those types of things. But for the sake of this workshop, we're just going to have a little bit of like a lazy load right at the top. So let me know when you're ready. Cool. What's up?
I love that you're doing retrieval augmentation. Are you pulling in any sensitive data?
Not in this use case, but that's a great question. Product-wise, that is a big problem, of course. There's kind of two ways to go about it. What we already have baked into our product is basically PII extraction, redaction, and then rebuilding out of that. So what happens is these large language models are actually pretty good at coming back with like templated responses. And so if you kind of go in, you redact the PII, you maintain kind of the audit log and what was happening for that specific request. And then when you get the data back, go and plug those results back in, kind of like what we've been doing with like the letter generation use case. You can avoid sharing sensitive PII with the large language model provider. The other thing, of course, that you can do just for additional safety is we have like MSAs set up with OpenAI and Anthropic as well to make sure that none of the data that we share is used in retraining in like any sense, right? But even then, like there are other steps, especially now with kind of how open source models have been developing. There's some really exciting stuff that's happening with like the open source space where at that point you can just kind of spin it up locally. They're not perfect. They do have their flaws. They get better with fine tuning. But yeah, there's quite a few different ways. In this use case though, and for this workshop, the data is straightforward. We're actually as you'll see, if you actually pop open the data folder over here, these are basically just the FAQs from the branch insurance website. So publicly available data, nothing too crazy. But if you do have data privacy concerns, those are a few different steps that I would definitely recommend kind of exploring with regards to how you can protect that core sensitive data.
As the customer support agent, you are generally exposing the LLM to the customer, and you have done a little bit of prompt engineering in the beginning. So if the customer now starts doing injection attacks against the LLM on the front, like you're not vulnerable in terms of your sensitive data because you are not even pulling that in during retrieval augmentation.
Mm-hmm.
It would be like logically plugged into the strings that you generated afterwards based on the token of the customer.
Yeah. Well, you wouldn't be sharing that sensitive information with the large language model provider. And then the way that you would avoid sharing sensitive data that is not authorized for the user to have access to really just comes down to when you're already fetching that data, you should only be fetching based off of their authorized token, what data they have access to begin with, right? And so that kind of the authorization layer of what the user even has access to begin with, or the customer has access to begin with, already just kind of goes through its authentication authorization flow, right? But then to ensure safety and compliance like the large language model provider, right, that's what I was talking about with regards to PII redaction and reconstruction. Yeah. But we're not doing that here. That's out of scope for today's workshop. Cool. Do we have index lazy load? There you go. Cool. Next step, the goal is we're just going to be adding in a few helper methods as well as our load index function. So you'll see here with that lazy load that we have at the front of our handler, there's a load index method. Load index method is going to be pulling in those files, as I mentioned, from the data folder. And then we just have a couple of other helper items in there called like add item, which what it's doing is it's going to go to the index. It's going to insert an item. It's going to go and get the vector from another helper method over here. And then it's going to add the text as metadata. If we go and we look at the get vector method, what's that doing? Oh, okay, it's calling OpenAI. It's creating an embedding. So it's running that process of taking that high dimensional text, reducing it into a lower dimensional vector, passing in that text, and then what we're doing is we're just going to respond with the embedding there. So let's go and let's take that code in. Actually, I'm going to go drop this a bit higher. Drop this above our prompt. And then the only other thing is, again, since we're kind of loading locally, the goal is to take our file system helper. Cool. And if everything worked as expected, you should be able to go node, start up your server. And if you hit your backend, you should get a little message down here saying like index loaded in your prompt. And then actually the fun part now, so you'll see we get back the response. We're not using this retrieval augmented or this retrieval based workflow yet with regards to how we're updating the prompt yet. But you'll see if you go to index and you go to index.json, this is actually like the data that's inside of your vector database, right? So you'll see the different pieces of text. You'll see the ID for that vector. And then you'll see a bunch of negative ones to one or whatever, where each of those effectively make up, your overall vector. Another way to think about these vectors again is just like the way that vectors are really defined is really they're a point in space, and then it becomes a vector when you take the line from zero to that point, right? So in like RGB, for example, as we brought up a bit earlier, the vector of like 111, right, is actually a point from 0 to 111. So a way that there are a few different distancing mechanisms to actually capture similarity. One of the most common ones is like cosine similarity, where what you're doing is taking each of those vectors and then you're actually calculating like the angle between those vectors. Another one's just like distance. There's a bunch of different similarity mechanisms that you can use that then affect actually how the overall search results come back out from your vector database. Cool. So does everybody have their index.json loaded? Does it work? Like, do you see data in there? Yeah? You're good? Cool. All right, awesome. So now that we have our index loaded, we can start querying it. So super simple little helper method, given some text. We're going to go and we're going to query. The other thing that I want to point out as well that I forgot to mention is just that when you're dealing with support, another reason for using semantic search versus keyword search is users don't typically know what they're asking about. Like they don't know what the specific terms or like the specific verbiage is. And that's where tools like semantic search really can help, because like they semantically kind of sort of know what they're asking about, but they don't really know like the specific keywords. They don't know your product in depth. They don't know the kind of like differences. They don't know that your checking account is potentially called like, cash exchange, whatever, something like that, right? So that's also another place where semantic search can really help. Of course, the downside is when a user has like strict keywords to ask for, that's where it kind of starts to fall apart, but you can use other techniques like hybrid search where you're using both sparse and dense vectors. Right now we're just using dense vectors, but you can actually use both sparse and dense vectors, where sparse is really mapping to like keywords, and the dense vectors are mapping to more of this like semantic core understanding similarity, and then you can actually kind of tune the amount of sparse versus dense and the balance of that with regards to like how you actually get your search results. Cool. So now we have the query method in, and then really the goal here is to take the question that we got, go and fetch an embedding for it, and figure out what pieces of text are similar to it, right? So let's take the question. We're gonna get, using that query, we're gonna take we're gonna get some relevant context. And then we're going to pass that over to our build prompt method. And then, as you mentioned before, right, the triple quotes inside of build prompt, what we're going to do now is with that relevant context, we're going to just pass that in to be like dynamically loaded into our prompt as we ask questions. So let's get rid of cool. And just for the sake of seeing kind of how the prompt changes, I'm going to recommend just adding in a console log. So as you kind of place those requests, you can see how the context actually changes. So when you ask questions about, say, car insurance, you'll actually start to see like the car FAQ and the car insurance related questions kind of coming in as context. When you ask questions about home insurance, you'll start to see that come in. When you start to ask questions maybe more about like your personal information, like how does branch know my current insurance policy? Or my car information, et cetera, you'll see that the context is dynamically changing. Overall, the large language model still believes, hey, I am a support agent for branch insurance, but the context that we're providing it is kind of like as you're dealing with a customer, you have just a different website open to help you answer those questions. And that's effectively kind of what's happening, but at like an AI, large language model scale. Cool. So. So, simple question. And we can see, get some basic context about like what is branch, like what is Everspan. If we ask it a question, I don't know, let's say, what is BI and PD, bodily injury? Actually, let's ask about that. Yeah, like what is bodily injury? And if you actually look over into your console, you can see that the text is dynamically changed out for looking at actually like our car insurance FAQ. Now, what you'd want to do, of course, is depending on the use cases, depending on how this kind of grows, what are all of those different data sources that you kind of want to start to hook up, make accessible to actually go about like resolving a ton of different questions. So in the case of like branch, for example, a lot of this comes into looking at like state availability maps, or just like the differences per state, right? So, if you want to know, hey, like in Texas, or you have the context about the fact that the user is in Texas, you can actually just start to use that and automatically refine and jump to those, responses in those questions. Cool. All right. Any questions so far? No?
Is it arbitrary that you just chose like the first relevant context instead of like if there's multiple relevant contexts and then build prompts?
So you can, yeah. So at this point you can do whatever you want, right? You can start to like loop in multiple pieces of context. There is a whole thing though to like start to realize when you start to loop in multiple pieces of context that if you don't loop in like the right pieces, or you don't kind of run a refinement before that, like you can start to actually confuse the model, and it can actually start to hallucinate across pieces of context. So like you might ask a question about like car insurance, right? And like the user may be in Texas, so you have that context as well to kind of go about fetching like the right pieces of information. But you fetch something that's just generic for car insurance generally, plus Texas specific car insurance stuff. You loop both of those pieces of context in. Next thing you know, it's kind of like hallucinating its answer across both of those and kind of making its own leaps of faith across those pieces of context, right? So that's where a lot of the guardrails and a lot of the you have to kind of be very smart about which pieces of context. And so really the simplest form is just adding like the top search result and kind of going from there. As you start to expand that into like other pieces of context across other forms of knowledge, other places of knowledge, et cetera, then you can get higher fidelity in terms of like questions or the amount of questions you can actually like cover and answer and like automatically resolve. But you do have to balance that with the risks of like, how does this open up like hallucinations, especially across that like cross-context based generation. Yeah.
Could we try a silly question?
Sure.
Could you ask it how many late days are allowed for payments on my rocket ship insurance?
How many leg days are allowed for?
Late days.
Oh, how many? They said leg day. How many late days are allowed for?
My payments on my rocket ship insurance.
On my rocket ship insurance. Yeah, let's see. I'm sorry, but I am a support agent for branch insurance and don't have information about rocket ship insurance. Sounds like you guys should be getting into the rocket ship insurance game. I recommend, but see, that's fun, right? I recommend reaching out to rocket ship insurance directly. for information about their payment policies and allowances for late payments. That's a good one. Cool. All right. So if there are no other questions really quickly, for the most part, we're ready to go. Oh, yeah.
Okay. No, if you want to continue, I just was wondering whether like self-reflection and chain of thought are things that you're considering.
Not for the sake of the workshop. Yeah. But they're like with chain of thought, that's really useful to just help refine and also gut check the large language model. There's two forms. One is actually just chaining and having the large language model kind of create an output, self-observe, and then actually go about it. The other way of doing that is actually by going within the prompt engineering itself. And you'll actually see benefits sometimes to just asking it directly within the prompt, within the system prompt, to say like, think through this step by step. Right? One of those basically is baked directly, that chain of thought is baked directly into the call versus one of them is baked actually like externally. And you'll start to see a lot of those ones when you start to use like agentic frameworks. So LangChain has an example of this. You have like Llama. There's like quite a few of these different ones where it's just like they start to handle the observation to follow up ask effectively. Those are like, they've gotten better. I wouldn't say the fidelity is really like quite there yet for a lot of them, but yeah, we're not going to do that for the workshop. Yeah.
Kind of curious, like for the workshop, what would you say are like the biggest like differences between going from like something that's kind of like workshopable, like demoable, versus like branch the actual use case?
Yeah. So a lot of it comes down to so this microservice you can imagine is just like the little base nucleus starting point of what then ultimately needs to go into something that's in production. You have a lot of the questions that came up with regards to like PII and safety, guardrails. This is a very simple prompt, like a very simple, aspect of like prompt engineering. But when you actually take it to production in terms of what are all of the different data sources, how do you balance knowledge that's actually duplicated and replicated across different knowledge sources? Most places, like they don't have a single source of truth, right? Some kind of work really hard to, but like they don't, right? Like you have the same thing kind of said over again, but like slightly dated or not. Like you don't even know which one is true. You need to begin resolving like where the truth actually lies before you actually start to use that. Another big piece of that is really around like what data should you be using and then who has access to that data. If you can't hook into like the authorization directly in terms of like, especially in like the customer context, right? Like if you can't hook into the authorization of what that user has access to, then where do you start to draw the scopes with regards to the knowledge and the data that they do have access to? And then on top of that, ultimately, how are you then exposing this in the user's workflow? So with a lot of the carrier customers that we've been working with, it's primarily starting off with like human in the loop based workflows, especially for something that's non-deterministic like this. You're dealing with a regulated space, right? I mean, as much as people would love to just like let this thing go live and like have it resolve, issues, you do need kind of that like, what I'd say is that a lot of this stuff can help with pre-processing a lot of the actions that need to happen before you actually go and respond, or something like that, right? The goal, though, of course, especially for these regulated spaces, is that we can get to automatically, resolving these tickets, resolving these like low-level tasks before it actually comes up and becomes like a larger, has to get like human support or humans involved in the loop for like simple tasks. I don't view like, but yeah, does that answer the question? I know I kind of like jumped around with regards to like 3 different pieces of the stack there, but.
You can just sort of hear what things you mentioned, top of mind and jumping around.
Yeah. So it's a fun problem to have. But cool. All right. Yeah.
For the like embedding stuff you did, like a high-level description of like why, like what you use the embedding for. Like I kind of missed a little bit of it, but like I've passed context into the model, just like that content very deep. But what benefit does the embedding give you? Like, yeah, what the previous?
Yeah. So in an ideal world, we could pass all of the knowledge that we needed to provide to the large language model like at any point in time, right? In reality, though, the knowledge required to support some of these use cases or the information required to support these use cases is much larger than we'd be able to supply in one call. Also, the drawbacks of supplying all of that information at once in that call is one, super expensive. You actually end up with higher latency. There's just a benefit overall to slimming down the amount of information that you provide so that it can jump to the answer that needs to provide as quickly as possible. Other thing too is if you were to actually provide all of the information at once, you also end up kind of confusing the model, because if it kind of thinks that the answer is located here and there, right, within that big chunk of data that you've provided it, it might kind of jump around with regards to how it goes about answering the question. With the RAG, retrieval augmented generation, the idea is to fetch the most relevant pieces of information to the question at hand before you go about calling the large language model, right? Now, the reason for the embeddings is just for creating our semantic search. And so the way that we go about fetching those most relevant pieces of information is with the search index. And the mechanism that we're using for that search index is semantic search. And the semantic search is powered by those embeddings, right?
You're essentially creating the embedding, fetching which data you need to pass into the context.
Mm-hmm.
So you're still just passing a string that is context into the prompt. But you're just doing the RAG for to figure out which string you should pass in.
Yeah.
Okay.
Right. And there are other ways too now that you can start to go about it with regards to actually starting to give these large language models tools to decide when they want to go and pull from specific data sources, right? When you start to give them different retrieval tools, et cetera, to go and figure out dynamically, hey, okay, I don't know the answer to this question. Let me go and pull from this source of data to figure out, when I need to find that. But again, just for the sake of the workshop, we're just doing a simple search index fetch, providing some additional context that's more tightly correlated to the question at hand. Yeah. Yeah. And then exactly, and then you have to deal with kind of the it's a balance again of is that faster to let it go and kind of chain of thought its way through multiple LLM calls to figure out that it needs to use that search index to answer that question, et cetera? Or is it easier to just go fetch it, use the call directly? Each of these calls OpenAI, they're not cheap and they're not even fast per se, right? They take a minute, right? So if you were to start, yeah. Yeah, and then did you want to know more about just how embeddings work generally? Was that also a question, or are you already
That part makes sense. It's more of how it factors into the code you're writing and how you're using them with the piece that I was missing.
Got it. Yeah. I think.
Yeah, I've seen a few demos of people showing the capabilities of AI in this way. But one thing I noticed interesting about your demo is that you did it via JavaScript and HTML.
Mm-hmm.
As opposed to doing a Python Jupyter notebook.
Yeah.
Was there a particular reason that you prefer doing it this way, or was it comfort? What's
I think it was just speed of development in terms of because at the end of the day, I think with a lot of just production applications and especially in a startup environment, you're building both front end, back end, all throughout the stack, right? And I think just with the maturity of the JavaScript ecosystem at this point, it's just the easiest place to kind of build across the stack for all of these different tools, all of these different integrations. So yeah, I've primarily been using JavaScript. Was that what I was using at Google per se? No, it was C++ and stuff like that, right? So, but at the end of the day, I feel with any microservice architecture, the whole point is to be able to be flexible and replace components as easily as possible. I will say though that with regards to a lot of frameworks, I definitely would love to see better support for large language model based work around JavaScript. The ecosystem around Python is pretty healthy. Yeah, I mean, and then you even have multiple orchestration frameworks already. You have people competing on that space, and so I've actually even given that as there's a lot of opportunity to build, not just in JavaScript, by the way, but just open that ecosystem up across JavaScript, but even Ruby, Go, et cetera. I would love to start seeing orchestration frameworks outside of just Python and JS as well. Yeah.
on the
So, actually, no. So the text, the amount that it's bringing back is predefined as part of like the pre-processing. So when you pass in a chunk of text, you generate an embedding, and you're typically going to store the embedding along with the text. And so when you go and you get the embedding, what's happening when you like get the queries, you get an embedding, you figure out what vectors are similar to your queries embedding or your questions embedding, and then you know that that embedding correlates to the piece of text that you had. And so that is ultimately like what you're pulling back, is that text that is correlated to that embedding. There are other pieces that you can also do on top of that where you can actually start to fine tune your embeddings. It sounds fancy, but really all you're doing is running matrix multiplication on top of your vector. But as you start to collect feedback from your search results, let's say you have like an open-ended search feature and you see that users are clicking on like number 2 or number 3 with regards to a specific question. Well, if you're running that same thing, then you know that, oh, actually a user preferred number 2 or number 3 instead of like the first result. You can actually just start to run like embedding fine tunes that way, but it's really just like matrix multiplication in that case. Yeah.
I just wanted to answer to that question because you said what's the trade-off a little bit around like how much do I want to retrieve around there, and you're right. It's like it's a search problem. It's not an AI problem per se. What I bring in, and so however you would want to design a search engine with like metrics like recall and precision, etc. That's how you would think about this. But the problem is if you then put it into the large language model afterwards, then you pay a tax for putting a longer context in because it starts taking longer to use GPT-4 and you paste a lot of context. That has quite a big window now. Then it might take 40 seconds to come up with the response. And there have been a couple of studies out of Stanford that have shown that if you put a lot of context in, it actually doesn't pay attention to most of the context anymore. So it like looks at the beginning, looks at the end, and the middle part is kind of lost. And as you correctly pointed out, if you put different kinds of context and it hallucinates across. So you want to like approach it as a search problem. What is the right context that I want to put in and be as precise as possible?
The thing that you were talking about as well is typically referred to as like chunking strategies. So the size of that text chunk, right? And then on top of that, there are like a ton of different underlying strategies that go on there. You have kind of like parent-child chunking strategies where what you do is like you embed like a large, like you're getting the embedding for like the smaller pieces of the document. Let's say you have like a large document, you get embeddings for like the small pieces of the document, but then what you're actually fetching as context is the parent document to pass in to provide like tighter matches, but then larger context at the time of generation. So there's all sorts of fun and exciting and like a whole world of strategies and things to experiment and try out. Yeah, what's up?
I'm curious, on the like retrieval of with levers that you can pull, like which levers do you think actually matter the most?
Ooh, good question.
There's so many levers, right?
That's like,
Should I use a different vector DB? Should I like pull in more information? Should I fine tune embeddings? Should I use different embeddings?
vector DBs, if we go to vector DBs, I don't think it matters unless you're like, in fact, I don't even think it makes like I don't think it makes sense to even be using one until you're like at, 1 million vectors plus or whatever. A lot of that is basically throwing like a bazooka at at like your embedding problem or your vector problem. But I think with the ease of how they like just get it spun up and like that, then it's like okay, it's fine. For the majority of cases, using like Postgres like PG vector is more than enough, right? With regards to embedding strategies, it depends. I think it really comes down to like a mix of what you see work for like specific context, specific way that like data itself, the underlying data itself is already organized. Because effectively what you're doing is you're ingesting that and then you are reorganizing it to be effective inside of your own application, right? And so depending on how like the core data itself is already organized, you then need to figure out, okay, how do I go about like restructuring this effectively for reuse within my application? And so the embeddings themselves, I mean, there's bandwidth with regards to exploring just like different hybrid strategies. Even like the OpenAI embeddings, it's like 1,500 dimensions. And that's actually really, really high, right? It's actually pretty unnecessary for the most part. Like you'd probably be fine with like 512 or like, 100 something dimensions. And in the early cases, like I don't know if it necessarily matters. Like the goal should really just, the thing that OpenAI did well is they just made it very easy to generate those embeddings versus like a lot of different embedding models. You're like going to Hugging Face, you're like figuring out which one works, you're like looking at weird like, results in terms of like, okay, according to like this benchmark, this embedding did that, and like, so there's a whole world with regards to just experimenting and trying these things out. Probably the best way to go about experimenting with this stuff is just running side-by-side analyses and trying to see like, okay, do those results actually look good? If I were to like actually run these two results side by side, which one actually tends to do better or perform better, et cetera? That's like, even inside of Google search, that was like the like gold standard in terms of actually like generating and figuring out which search results were better before you actually took it, ran an experiment with it, and then looked at like higher level user metrics, right? You'd run like tons and tons of human evals and side-by-side evals. Cool. All right, so last step of this is actually like deploying this thing. Do you guys want to deploy it or no? I mean, it's really simple to deploy. That's what, I don't know.
I mean, it's a serverless function, right?
Basically.
Well, no, it's a container running on fly.io.
Yeah.
So Fly does say that they want to verify my account with a credit card before I can deploy that.
Yeah, so I mean, the remaining instructions to deploy are super easy. You're basically just gonna do like fly launch. That's gonna set up this fly.toml file, which basically is just like, okay, this is how you're gonna go about, this is how your launch is configured. You're just gonna wanna make sure that like both on the YAML for the fly file as well as the Docker file that you're exposing ports 8080. Then you just wanna upload the secret, basically your OpenAI secret, and then you're just gonna say fly deploy, and that's it. Your thing's deployed up on Fly. You have your early nucleus of an LLM-based branch insurance support agent live and running. Yeah.
Where's sort of the interface between like making the question that's asked, the model decides, yes, I can answer this, or you know what, no, you need a live person.
Great question. That's another thing that we actually have baked in as well. Escalations, effectively, right? And actually, the very first meeting that I met Joe, he was like, "You guys need to handle escalations." Like, it's like, and yeah. So really, the what you want to do, there are kind of multiple ways of going about that. One, you can use, large language model or another model afterwards to kind of validate and verify the answer that was generated. To say like, okay, is this even topically correct? Am I like checking for hallucinations? And if it is hallucinated, responding with a canned answer, basically saying like, setting a flag, saying like, okay, it's time to escalate this. Another thing is actually just through prompt engineering itself, saying like, hey, if you don't know the answer, like just don't make this up. Just tell me you don't know it. And then looking for those key markers of like, yeah, I don't know this, to then set your own escalation flags within your own application and then route accordingly. Once you start to have those escalations set in, there's actually a lot of other fun things you can do around like intent-based escalation and whatever. So specifically inside of insurance, all right? It's like, do you want to escalate this to an underwriter? Do you want to like escalate this to a claims rep? Do you want to escalate this? And then on top of that, with multi-line carriers, right? Do you want to escalate this to like a home claims rep or an auto claims rep, somebody that specializes in that? And you can start to infer that intent just off of these questions automatically and off of kind of the use case or like what's going on inside of that customer's profile, to then start running those kinds of like, escalations and those deflections directly up the chain. The other thing too is if you were to actually start to expose this directly, this is one shot, right? You ask it a question, you get an answer. What you want to actually do when you're getting into like chat-based functionality is start to apply memory behind the scenes, right? So keeping track of the session, keeping track of the conversation that's going on, and then potentially like dynamically choosing when to retrieve and when to not. So for example, you have a question. If I was speaking with like a support agent, I have a question, the support agent doesn't know the answer, the LLM support agent doesn't know the answer, goes and fetches data, it comes back, and then I'm like, thanks, have a great rest of your day. There's no reason to be running like another retrieval for that, right? You just want the LLM to reply like, have a great rest of your day, bye-bye, right? So there's a lot of stuff that goes into actually also making that dynamic versus if you look at it right now, what we have here right now is just like pretty brittle in that sense where every time a question comes in, it's one shot, it's going, it's fetching from the index, it's populating the prompt, and then it's returning an answer, which is great for resolving simple questions and like simple cases of like, self-service workflows, or like, even inside of, what is it? Just like, instead of searching through docs, being able to just ask this question, get like a concrete answer back. It's actually grounded and factual. But yeah, as you start to bake in other tools like memory and stuff, you can actually start to, do some of these other like really fun and exciting things as well. Yeah.
Maybe this is a question for both of you guys, but you were saying like right now, since everything's sort of regulated, it's human in the loop. How would you say, like, what would you say is the main benefit while it's sort of like at the stage where it's human in the loop? What those methods of human or like from a branch side until you get to the point where it's like, oh, the regulators are happy with it?
Yeah, and I would say in insurance regulation, the regulators aren't really regulating this all that much. But so there's a huge benefit in helping our internal support reps find information. There's an enormous benefit also, as Arvind said, in pre-processing a lot of information. So you can imagine you get a lot of emails in or text messages in, and there's an existing conversation behind it. Understanding that is really important. Also, we have phone calls and we have a 24-hour callback guarantee. And so we use Dialpad, which automatically transcribes everything. Those are long transcripts. So what did that actually talk about in order to be able to get that context and a suggested answer, solution, whatever other information in there? And then we have a claims use case too, where there's a tremendous amount of time and effort that's spent. You give a fact, you get a series of facts of this is what happened, and then you have an insurance contract, and a lot of times what you had wasn't covered by the contract. And so writing the letter to say, well, that set of things isn't covered by the contract because the contract had this particular language in it, and that's where the exclusion is. That type of, or it's limited in what the claim can be. Those things are all really useful. I mean, I would love, you can imagine the iterative process that gets this direct to consumer. I think the most obvious path is, we're pre-drafting email responses. So emails come in, we pre-draft a response that says, we think this is what it is, and it's there waiting for the rep to see. And then Kyber can go see, did we use it? What did we change about the response? And that's a really natural way to get to if 95% of the time we're just sending what Kyber said, then just send it. I mean, there's an error rate in humans too. And so what you have to do is design the deployment in a way so that everyone can be on board with, we understand what this error rate is, and we understand that the errors that are being made are like harmless essentially where they are. I don't know if you would.
That was great. I mean, and I think that also just comes back into like the productionization of these applications. There's a huge opportunity to like just pre-process a ton of like pre-existing knowledge work already. And then as Joe mentioned, like how do you begin to like bucketize, the difference rate? What cases fall into like the different buckets, and how do you slice that out? For the cases that are super simple and easy and like we already see a really high reply rate, let's just start to automate those directly. The cases that are failing, why are they failing? Is this because, we need a better integration into like a policy admin system? Is this because the backing data or something doesn't really expose this yet, or we just don't have pieces of content that can answer and resolve this, and that's why we're ending up in this like weird state? Is it just the fact that like the format that would be ideal to reply in terms of like the templated email is just not the format that we've been generating? Oh, that's like an easy fix. Let's like just throw in a piece of content saying like, when you deal with these cases, reply in this format and ask these standard set of questions and stuff like that, right? And so all of those then just give the large language model and help to like further automate and build these cases out to then effectively, get to that point where it's like, yeah, let's just let them automatically reply, resolve, and just have this conversation directly. But since it's regulated, you just want to make sure that, because everything you send in writing, it's in writing now, right? And so you got to be careful. Yeah.
And it sounds like a huge benefit already, like with the summarization part, because
Yeah.
support agents are very busy. They can't pull in context that quickly.
Yeah.
Cool. All right. Well, I think we're like right at time. 2 minutes left. But any other questions? Also, we'll be around. I mean, right here. So cool. All right.